Hello everyone. Today we'll talk about the solution to the problem move pieces to obtain a string. What we can notice immediately is that since we can only move the characters into empty spaces, we can never exchange the positions of two different characters. Even if we have a character R and then a character L, so they could in principle move in the correct direction, we cannot swap them. And what that immediately gets us is that the order of L's and R's within our sliding puzzle will never change. And more specifically, it means that when we are looking at start and target, we know exactly which piece every letter represents. It has to represent the same piece. So the first piece has to be the same in both of them, the second piece, and so on. And so we can check that. We can check if the types of pieces match. And if the types of pieces match, we also have to make sure that it's possible to transform one into the other. And of course, that's where the moves come into play. So when we see that the two matched pieces are a left piece, then that piece in the starting position, in the string start, shouldn't be to the left of its position in the string target. And mutatis mutandis for R. When we see an R in start corresponding to an R in target, then that R in target cannot be to the left of the R in start, because the R in start can only move to the right. And we can simply just now look at it in linear time by just traversing both of the strings. So if n is the length of the string, we'll be maintaining the current position in the first string, and we'll be going through all the characters of our target. We don't care at all about empty spaces, though they will still, of course, increase j, so it's not like they don't change anything. And now, we have to find the next non-empty character in start. So while the character is this floor character, we increase I. If I is equal to n, that means that we have fallen off the end of the starting string. So we could not find a match for the character j, so the target of j, which is not equal to an empty spot. So we immediately return false. And now, the corresponding characters, which are not underscores in this position, have to match. So if they don't match, we return false. And now we check for L and R that the correct inequality is correct, or rather does not happen. So if the letter is L, we want the position in the starting string not to be smaller than the position in the ending string. And the reverse if the character is R. In that case, we return false. And now, since we're automatically incrementing j, we have to remember to increment I, because now we've eaten this start of I. This letter was matched with target of j. And we can return true after we make sure that anything that remains in our starting string is just empty spaces. So we increase I until we fall off the end of the string, and if at any point we see L or R, so something that's not an empty space, we return false, because while we can create the prefix matching the string that we are given here, but still it might be that there are some L's or R's to the right of the starting string that make the two strings incompatible.